Okay, so we're going to look at, we talked about relations last class. We're going to look at now what makes a relation or a special kind of relation a function. So we have a relationship between two things, but now we want to see if that relation is actually a function. So we'll start with the definition. In order for a relation to be a function, each input value, or x value, must be assigned to one output, or that's a y value. Okay, so every input must only have one y value. So identify whether or not each relation is a function. If not, explain why. So this one is a function. Because each input value, 2, maps to only one y, 3. 1 maps to 0, 0 maps to 6, negative 1 maps, each one maps to only one value. It's okay that 1 maps to 0 and negative 2 also maps to 0. If I were to do our mapping diagram, right, I would have negative 2, negative 1, 0, 1, and 2. Negative 2 would map to 0. Negative 1 would also map, negative 1 would map to 5. 0 would map to 6. 1 would also map to 0. And 2 would map to 3. So it's okay if two input values map to the same output. You can't have an input mapping to two different outputs. Here's what you can't have. I'll put it in a different color. If negative 2 mapped to 0 and also mapped to 5, that would be one input value mapping to two different outputs. That would make it not a function. Because it says each input must be assigned to one output. It doesn't matter if that output's the same. Let's look at this guy. This is not a function because negative 2 maps to 4 and then negative 2 also maps to 1. So if I did my mapping diagram of input and output, negative 2 would map sometimes to 4 and other times it would map to 1. That makes it not a function because there's two branches coming off here at negative 2. So not a function because negative 2 has two different y values that it maps to, or outputs. You can also, on a table, it's helpful to look at, does the x value repeat? Okay. Now let's look at states and their capitals. Is that a function? I'm going to say yes, this is a function. Why? Because each input state can only map to one capital. A state can't have two capitals. New Hampshire maps to Concord. New Hampshire won't also map to another one like Boston, so that is a function. Here's our mapping diagrams here. Let me see, make sure I'm reading the directions. Okay, so this is not a function. And if it's not, I have to explain why. Because 1, the input value of 1, I'll say because the input of 1 maps to two different outputs. So each input has to have exactly one output that it maps to. E is yes, it's a function. Because each one, 3 maps to one number, 9 maps to one number, 4 maps to one number. It doesn't matter that 3 and 9 both map to the same output. Doesn't matter as long as they go to only one. F is also a function for the same reason. Each person maps to only one thing, to one sport. Okay, let's look at G, some ordered pairs. Is this a function? Again, a little cheat here when you have ordered pairs or tables could be to look for x values or input values that repeat. So do I have any repeat customers here on the x? I don't. So that means each x maps to only one y value or one output value. So yes, it is a function. H, I'm scanning looking for any repeated x's. Oh, I see 3 and 3. Now I have to make sure that they map to different y's, and they do. Sometimes 3 maps to 4, and other times 3 maps to 3. Again, if I made a mapping diagram, 3 would sometimes map to 4 and sometimes map to 3, right, if that's my input and that's my output. That makes it not a function. So no, it is not a function, because 3 maps to 2 different y values. All right, let's move on here. Take a look at the next thing. So we want to talk about domain and range now. These are new words that we're introducing. So domain of a function is the set of all possible inputs, or remember, x values. I remember this because D comes before R, so input comes before output, right? I comes before O, X comes before Y. So it all matches in the alphabet. D comes before R. So range is the set of all possible outputs, which are Y values. So using those definitions, let's talk about domain and range. So for each function in exercise 1, identify the domain and range. So if we look back to A, the domain is going to be all the possible inputs. I'm going to erase that stuff. Actually, wait, I should leave the answer in there, but I'll erase this. So your domain is all your possible inputs. It's all these numbers: -2, -1, 0, 1, and 2. And when we make a list of stuff, we're going to put it in fancy brackets. Range is going to be a list of all the possible outputs: 0, 3, 5, 6, I think it was. Yeah, 0, 3, 5, 6. Notice I didn't repeat the 0. And notice I put them in order. I went 0, 3, then 5, then 6. I put them in numerical order. All right, B. Well, B was not a function. So it said for each function, do this thing. So not a function, we can skip it. C, list the domain. That was the state. So I think we had Connecticut, Maine. You can pause the video and go back and look if you like. Massachusetts, New Hampshire, Rhode Island, and Vermont. Those were all our possible inputs, so that's our domain. Our range is all the possible outputs. It was all the capitals: Augusta, Boston, Concord, Hartford, Montpelier, I don't know how you say that, and Providence. Squiggly brackets. All right, D. D was not a function because of 1. E. My inputs were 3, 4, and 9. Right? Those are my possible inputs, and my possible outputs are -9 and 0. F, we were talking about athletes, so we had Manning. Our inputs were the athletes: Manning. We had Serena Williams. Oops. And then I think it was Tiger Woods. Again, if you don't believe me, you can pause the video and check for yourself. The sports they played, let's see, Manning plays football. So the range was the possible outputs. Williams plays tennis. Woods plays golf. So those were our outputs. For G, it was numbers here. So our input was G, 2, 4, -1, 6, and -2. And I'm going to put those in numerical order starting with -2. So we're going to have -2, -1, 2, 4, 6. Now we have to do our range, our possible outputs. I think it's 0, 1, 3, and 8. The last one was not a function. All right, let's look at the next part. We want to identify whether or not each one represents a function. So if you have a graph, how can you tell if the graph represents a function? We're going to do the vertical line test. Okay, the vertical line test, you're going to draw multiple vertical lines through the graph. If any line hits the graph more than once, this breaks our definition of function. So it is not a function. I kind of think of having one line and just dragging it across and seeing if it ever hits twice. Okay, so what I did was I made a vertical line here. You can think about if I drag it across, right? So if I drag this vertical line across the function, is there ever a spot where it's going to hit twice? Hit the graph twice. Now this graph is just a bunch of dots. There's no dots that are on top of each other, so no, it's never going to hit twice. That means it passes the vertical line test and it is a function. Over here you can see that right here it'll hit the graph once, but everywhere else it's hitting twice, hits the graph twice. On all these x values, it's not a function. Because think about this x value right here. This is an x value of 2, right? An x value of 2 has 2 y values. So that means one input maps to 2 outputs. There's only one other time where there's 1, right over here again, where it touches. So all these spots in here make it not a function. It failed the vertical line test. Okay, so this one is a function. So we'll say yes, it is a function. And this one, no, it is not a function. Because it fails the vertical line test. And again, to fail the vertical line test means if you can draw a vertical line that hits the graph twice. So I kind of asked myself, is there anywhere I can draw a vertical line anywhere on this graph where it will hit twice? If it can, it fails the test. I don't see a spot where I can draw that, so it must pass the test. So yes, it is a function. Here again on this next one, I'm trying to find a spot where could I draw a vertical line that would hit the graph twice. I can't. So I'm going to say yes, it is a function. All right, so now we're going to look at some data here. You're an altitude of 250 feet in a hot air balloon. You turn the burner on high and rise at a rate of 20 feet per minute for 5 minutes. Your altitude after you have risen for t minutes is given by the function. Make a table to show the altitude. So number of minutes. If I plug in 0 for t, I get 250 in altitude. Now if I plug in 1 for t, right, I'll get 270. You're going to pause the video here and get ahead of me and fill out this table by plugging in all those number of minutes and see what altitudes you get. Okay, so this is what you should get. Next up, we want to graph that data and we want to label our axes. So on this axis, it's number of minutes. On this axis, it's altitude in feet. So we start at 250 for time 0. And then we kind of go, 1 is 270, so maybe it's like there. Then 1.5 is 280, and then 2 was 290. Right, so we just kind of keep plotting these points. 3 is somewhere like around there. 4, we're like here-ish, and so I can see a line developing until I get to 5 at 350. And then what happens, we don't rise anymore. We're going to stay at that altitude, so we can say that the balloon stays there. Stays at an altitude of 350. Does it make sense to connect the points on the graph? Explain. Yes, it does. This is because the altitude is being measured over time. So time is continuous. The time clock there, it's constantly running. So I don't have to put dots. I can have a smooth, like I draw a line. Okay, after 5 minutes, you turn the burner to low. This gives just enough heat to keep the balloon from falling, but not enough to make it rise. Plot a point on the graph to show how high it is after 6 minutes. So that's this point right here. I was saying we're going to assume that it stays at that height. It doesn't get any higher or any lower. So we plotted that point. Does it make sense to connect the point plotted in part D to the rest of the graph? I believe it does because, again, time is continually passing. So even though the altitude is not changing, the time is still passing, and it's continuous. Okay, what's the domain of this function? So I'd have to list all these x values. So what we do is we're just going to say it starts at 0 times 0 and goes on indefinitely. We don't know how long they're going to go on this ride for. So we're going to say the domain is all t such that t is bigger than or equal to 0. I just used a lot of fancy words in there with these symbols. We're going to talk about those in class. You should just worry about right now this part. Do you understand that part? That's really the meat and potatoes. The domain is any t value, any time bigger than or equal to 0. Now what's the range of the function? Well, the lowest y value, because range is output, is 250, and then it goes up, but it does stop at 350. So that range is going to be a height, or I'll say, whoops, sorry, say range is going to be all heights such that the height is in between 250 to 350. So I can write it like this. And again, you really just want to pay attention to this part. I'll talk about the other stuff. You want to say that h has to be in between a height of 250 and 350. Okay, on this last one, we'll go through this one, and then you can start some practice on your own. So you pause the video now and read the problem. Okay, welcome back. So the equation that we're going to write is P equals 14.7 plus 0.445D. Okay, so 14.7 is that initial pressure at the surface, and then the 0.445 is how much we add every time we descend. The further down that we dive, the pressure gets greater and greater. So we're going to use that equation to complete the table below. We're going to plug in all these x values or d values in for D and find out what the pressure is. You should pause the video and do that. Alright, so this is what you should get. So now we want to make a graph out of those data points. So 0, 14.7, 20, okay, then 40. So you can pause the video and finish this as well. All right, so you should get these data points here, and we can make a graph here. We had to do 100, and it should be, yeah, it should, yeah, okay. Do I have that right? Let's see. Okay, so that will be your graph. Now let's move on. Describe in words why this is a function. So I'm going to say this is a function because it passes the vertical line test.